Today I want to do a quick review of solving quadratics by completing the square. Well, first we're just going to work on completing the square. So in my problem, a squared plus 5a plus something, to make this a perfect square trinomial, then I have a particular method I want to use. I'm going to take my middle term, 5, and divide it by 2, and square it. This is the same process that we will always use to find our third term here. So, 5 times 5, and 2 times 2, so that leaves me 25 fourths to add in that spot. Now to factor it. You'll notice that there's a pattern with these that works every time. But today I will show you using the distributive property. A squared plus. Now I need two numbers that multiply to give me 5, but multiply to give me 25 fourths. You'll notice that 5 halves plus 5 halves gives me 5. But if I multiply 5 halves times itself, it gives me the 25 fourths. So I'm going to break down my middle term of 5a into 5 halves a plus 5 halves a plus 25 fourths. Now using grouping, I'm going to take the first two and find a common factor. As I look at that, I see that they both have the variable a. So I'm going to take that from both terms. A squared is a times a, so if I take one of those out, I still have an a. If I multiply it back together, a times a is my a squared. Plus 5 halves times a. Well, if I take that a out, again, I'm left with my 5 halves. It is a common factor of an a. And I'm going to take my second two terms. I look at those and I have to find something that is in common to them. Well, I need to remember here that 5 halves times 5 halves is my 25 fourths. So both of these have 5 halves in them. That would be my common factor. So if I remove the common factor of 5 halves, I'm left with an a plus 5 halves. Notice that my two parentheses are exactly the same. Therefore, that now can be factored out. And the a plus 5 halves is left to go into our second parenthesis. Notice that our two parentheses are exactly alike. Therefore, this can be written as a plus 5 halves squared. Now, let's solve using completing the square. To solve this, I need to keep the n squared and the n term on the left and move the negative 76 from the left side. So the opposite of minus 76 is to add 76. So n squared minus 20n equals 76. Now to complete the square, I need to add something, but I cannot just add it to the left. I must also add it to the right. To find the value that I need to add, I'm going to look at my middle term, negative 20, take half of it and square it. Negative 20 divided by 2 and square it. Well, negative 20 divided by 2 is negative 10, and negative 10 squared is 100. So that is what I must add to both sides. That leaves me here n squared minus 20n plus 100. And on the right side, I need to combine my terms and get 176. The left side now needs to be factored. Since I completed the square, I know that my factoring will be n, and then whatever the middle term, half the middle term was negative 10 squared. It will always factor that way. To finish solving this, I now need to work at getting the n by itself. I must isolate it. To isolate the n, I need to start on the outside and work my way in. On the outside, I see the square. Well, the reciprocal operation for squaring something is taking the square root. So I am going to square root both sides. As I square root this, these two operations, being reciprocal operations, will cancel each other out. So I have n minus 10 is equal to the square root of 176. Well, my n is almost isolated. I just need to get rid of my minus 10. So the reciprocal operation would be to add 10. And I neglected to remember to put my plus or minus up here. I apologize. Whenever you square root both sides, you can have either a positive or negative value. Now, this answer is not simplified. To simplify this, I need to see if I can simplify my radicand on the inside. So I have to think. 176. What multiplies to give me that? Well, I do believe that 16 times 11 is 176. If I keep breaking that down, that only breaks one way, to 11. 16, 4 times 4, 2 times 2 times 2, 2 times 2, and then my 11. What I have done is brought this down to its prime factorization. We've talked some about square roots. The square root of 4 is 2. What I want to do is find what I have pairs of them, because those pairs will become perfect squares. 4 is a perfect square, so the square root of 4 is 2. So since I have these pairs, they will now come to the outside of my radical, and my 11, the Lone Ranger, will stay inside. 2 times 2 is indeed 4. So my answer becomes n is equal to 10 plus or minus 4 square roots of 11.